Hey everyone, welcome to our lesson on inverses of quadratic functions. We need to go over some things about functions before we take a look at these inverses of quadratic functions. So first off, recall that when we're talking about inverses of any type of function and we are looking at the graphs of those, inverses are going to be reflected over the line y equals x. So that is that perfect diagonal line through the origin, y equals x. Any kind of functions that are going to truly be functions will have only one x value paired with one y value. So we can take a look at this in just a second, and we'll look at the vertical line test that tests for just this to make sure that each x is paired with only one y, make sure that what we're looking at is a function. And another term we need to talk about when we are talking about this special type of inverses of quadratic functions is called a one-to-one function. A one-to-one function will have every y also paired with exactly one x. So not only are all of the x's paired with one y, but all the y's are paired with one x. So we'll take a look at that on the graph in just a minute. And so since for one-to-one functions, each y is paired with only one x, the inverse of these functions, the reflections over that line y equals x, will also be a function. So it will make more sense when we take a look at the picture of this. Alright, so we talked about the fact that inverses are reflected over this line here, y equals x. So if we could picture ourselves turning the function over this line or rotating it around to be its mirror image on the other side, that is what it will look like. Alright, so for a quadratic function, let's take a look at a basic quadratic function here. Y equals x squared, which is going to go through the origin and the point 2, 4 and negative 2, 4. If we look at the inverse of this function, we are going to need to reflect it over that line, y equals x, okay? And sometimes it's hard to visualize that, so one strategy we can use is to reverse all of the x and y coordinates. So if we know that it goes through the point 0, 0, and we switch those, it's still going to go through the point 0, 0. Alright? If we know that it goes through the point 2, 4, our new inverse function is going to go through the point 4, 2. So we'll plot that coordinate. And if we know that the original goes through the point negative 2, 4, the new inverse will go through the point of those coordinates switched, which is 4, negative 2. So the inverse of this function would look something like this. Now, when we're trying to see if what we're looking at is a function, we use what's called the vertical line test. So if we take a look at our green quadratic here, and we perform a vertical line test, which is drawing several vertical lines through your picture from left to right. The vertical line test says that if we only touch one location on our graph each time we draw a vertical line, that means what we're looking at is a function. Okay, that's because, remember we talked about every x value only has one y value. So for this x value here, there's only one y value, one unique y value. If we perform the vertical line test on our inverse of this picture, we can see that we have a problem. We can see that at every vertical line we're drawing, we're coming in contact with the picture 2 times. We can only come in contact with it once for us to pass the vertical line test. So the inverse of this quadratic function is not a function for that reason. Okay, so we're going to take a look at finding the inverse of a specific example of a quadratic function, and then we're going to put this one on the graph. Alright, so we looked at the basic picture earlier. Now let's take a look at this one here. F of x equals 1/4 x squared. Now to find this inverse, we're going to have to use 3 steps. The first step is to replace f of x with y. We want to do that because our next step is to switch x and y. Inverses have all the x and y values switched. So if we're finding it algebraically, we're going to do the same thing in that process. And our last step in finding this inverse is to solve for y. So we need to get y isolated. So to do that, we need to get rid of our 1/4 by multiplying by the reciprocal on both sides. And that will give us 4x equals y squared. And then we are going to undo the power of 2 by taking a square root. Alright, so the square root of 4x seems to be our inverse function here of this quadratic, square root of 4x. So let's take a look at that on the graph. We had y equals square root of 4x. What would this look like? Okay, so we could take our graphing calculator and find some points on our table to go graph, or we could make an xy table and test some x values to find the matching y's. When we do that, we're going to get a picture, something like what we saw before. Okay, but you'll notice in your graphing calculator that you do not see that lower half of the picture that we saw earlier. We don't see the parabola wrapping all the way around. Okay, that is because if we use the negative values for x, as we saw before, we're going to run into a problem. We're not going to have a function. It will not pass the vertical line test. But if we restrict our domain in the original function to only positive values, all x values bigger than 0, then it does become a one-to-one function, which means the inverse will be a function, as you saw on the previous slide. So we could use the vertical line test on this here, and you can see that it now passes that test because it's only crossing the function one time for each of these vertical lines. Okay, so our inverse, let's review, of a quadratic function is going to be the square root function. The inverse of that power of 2 is the square root, and it's going to look something like this. This is the general picture, and it's not going to continue to curve around as an original quadratic would do, because if we use those negative values, we would no longer have a function. So this concludes our lesson on inverses of quadratic functions.